right, so we're moving on to lesson 5.5. So this is going to be lesson 5.5a. And lesson 5.5 has a lot of new formulas in it. But today we're going to talk about the double angle formulas. All right, so I have those over on the side. There are two of these that are on the challenge exam reference sheet, and they're the top two. The others, we can not worry. I mean, we're going to use them when it's helpful, but those are the ones we'll focus on. So for example 1, we're going to go back to equations to solve, but it's okay. We're going to solve in the interval from 0 to 2 pi. And our equation is the sine of 2x minus the cosine of x equals 0. Now, because this is definitely in the double angle formula lesson, we are going to use a double angle pretty much on every problem. So the sine of 2x, we can look up there at our angles, of our formulas, and we can rewrite it as 2 sine of x cosine of x. Right? Then we can solve this equation by factoring out a common factor, and that common factor is cosine of x. And we're factoring out of what's in front of the minus sign and what's after the minus sign. So when I factor out of what's in front, I'm left with 2 sine of x. And then when I factor out of itself, I'm just left with minus 1. Right, and then we'll set each of those equal to 0. Okay, and this one over here, I need to solve for sine of x by adding 1 and dividing by 2. All right, so the cosine of x equals 0. So anytime where we have cosine or sine is equal to 0, 1, or negative 1, we're going to go to the quadrant angles. And when I'm getting the we're getting the cosine from the quadrant angles, I use the x coordinate. So I want an x coordinate that is 0, right? And the ones that have an x coordinate of 0 are pi over 2 and 3 pi over 2. Okay? And then for sine of 1/2, or sine of x equals 1/2, I would use the hand trick. For sine is the square root of the top, so I want 1 top finger. I also know that sine's positive in quadrant 1 and 2. Okay? So 1 top finger. Oh, shoot, I said that wrong. I'm sorry. Sine is bottom. My bad. 1 bottom finger is pi over 6. That's the answer in quadrant 1, and pi over 6 in quadrant 2 is 5 pi over 6. So this equation actually has 4 solutions between 0 and 2 pi. Okay. And then for example 2, I'm going to use the double angle formula to rewrite. All right. And so what I have on example 2 is the cosine of x plus sine of x multiplied by the cosine of x minus sine of x. Now, if we look at our double angle formulas, that doesn't really look familiar at all to me. So what we're going to need to do first is just go ahead and multiply. And because of the way these are written, they're kind of like conjugates, I can do a shortcut to multiply. So just multiply the cosines and the sines together. All right. Then when I look at that and I look back at my formulas, it looks like this right here. So then it must just be the cosine of 2x. All right, and then our last example is the long example. We're given that the cotangent of u is equal to -6, and pi over 2 is less than u is less than pi. What we're going to do is find the sine of 2u, cosine of 2u, and tangent of 2u. So let's think about what this means. That is kind of a fancy way to tell you that this angle u is in quadrant 2. If it falls between pi over 2 and pi, because if we look back at this one, in between pi over 2 and pi is quadrant 2. So what I would do is I would draw a triangle in quadrant 2. Oh, let me try that again. And this angle is u. Now what we know is the cotangent is -6. So that also means that the tangent of u is -1/6. So the opposite is 1 and the adjacent is 6. All right, and then to find the hypotenuse, we would just do the Pythagorean theorem. So that's the square root of 37. All right, so to find the sine of 2u, I would just use my formula. Let me move it. That's going to be 2 sine of u, cosine of u. All right. So what I need from my triangle is the sine of u and the cosine of u. All right. So in quadrant 2, sine is positive, and we do the opposite over the hypotenuse. Now this time, we're going to leave our radical in the denominator, because when I look at all these formulas, I'm squaring and I'm multiplying it by a cosine, so that radical is going to kind of take care of itself. All right, and then the cosine is -6 over the square root of 37. We're just going to leave the radical. Now, it won't be wrong if you don't leave the radical. It's just going to be easier if you do. All right, so it's going to be 2, and then I'm going to bring over my sine of u is 1 over the square root of 37, and then bring over my cosine of u is -6 over the square root of 37. And it might help you if you write that 2 as 2 over 1. You don't have to, but I'm going to. Okay. So I'm just going to multiply across the numerator. So 2 times 1 times -6. And across the denominator, 1 times the square root of 37 times the square root of 37. And that's it. That is what the sine of 2u is. Okay. Then if I want to find the cosine of 2u, I can use any of the formulas for cosine of 2u. There's 3 to choose from. I'm going to go ahead and use the one that is on the challenge exam, because that's the one I want you guys to be the most familiar with, which is the top one. All right, so I'm going to put in the cosine of u And then I'm going to square it, and I'm going to put in the sine of u, and I'm going to square it. Okay, and then all I need to do is subtract those. Okay, and then for the tangent of 2u. Now, I don't really like that tangent formula, so I'm going to use an old one that we all know, that the tangent of u is equal to the sine of u divided by the cosine of u. So for tangent of 2u, it's going to be the sine of 2u divided by the cosine of 2u. So I already found the sine of 2u was negative 12 over 37. And I found that the cosine of 2u was 35 over 37. Now, depending on how comfortable you are working with fractions, you might be able to just look at that and tell the answer. And that's great. If not, we would take the numerator and we would multiply it by the reciprocal of the denominator. And those 37s would cancel out, and you're just left with negative 12 over 35 is the tangent of 2u. All right. Now, if you wanted to, we could have used that tangent double angle formula and it would work. I just don't particularly like it. And it's not on the reference sheet of your challenge exam, so you would have to memorize it to be able to use it on the challenge exam. Okay, so on page 389, I want you to do those problems.